I want to give a few suggestions on homework 1.3 part 2. There's these 4 problems. In the very first problem, you're asked to find the slope of the tangent line to this function at a certain point. And we've done ones like this in class. We're going to use the limit definition of slope of a tangent line, which is the derivative. And I guess the important thing is in this problem, you have to decide what a is going to equal. And this is a big hint right here as to what our a always is. Then problem number 2 is similar to problem number 1. Again, you're going to use this limit definition of slope of a tangent line. But here you're not just finding the slope, you're finding the equation of the tangent line to this function here. So a new function at this point. So when you find the equation, not just the slope of the tangent line, it's probably a good idea to use point slope form of a line. You'll find this part initially just by using the slope of a tangent line formula right here, and then you have a point x1, y1 that tangent line is going through. It's already given to you in the problem. The other somewhat difficult thing about this problem, or kind of increased difficulty, is this function is a rational function. So when you are evaluating kind of more complex values of the function, you're going to have some kind of complex fractions that you'll have to simplify. And so just remembering that probably somewhere in the problem you're going to need to get some common denominators. So think about what it would mean to input something that looks like this or similar to that as an input value in this function. You would need to put that a plus h or whatever number plus h in for your input variable. That whole thing has to go in for your input variable. Okay, problem number 3, we're dealing with the population of India, and we have this formula. This is an exponential formula. And things go, there's a series of questions that you're asked about it. And this is not bad, this is not bad. This one, part C, you probably want to think through what the graph of this looks like and why an average rate of change would be one thing and an instantaneous rate at a certain point would be either smaller or larger. But graphically, you can kind of reason out that one. Okay, part D, write an expression involving limits. So we're back to probably using this. Write an expression involving limits that, if evaluated, would give the instantaneous rate of change. Remember that we talked about instantaneous rate of change is the same as the slope of the tangent line, which is the same as the derivative. All of those things are equivalent. Of the population on January 1st, 2025. Okay, this function is where t is number of years since 2000, so you can see that t is going to be 25 here. You won't be able to algebraically simplify this, but set it up as far as you can. So I'm looking for this, but you won't be able, so just take it as far as you can using this function and for what it's asking in this particular problem. But you will not be able to simplify it all the way. This exponential function just won't let you do that. So that's why I wrote this sentence here. Estimate the instantaneous rate of change of the population on January 1st, 2025, and you're going to use a close point. Because in part D we realized we couldn't algebraically do it, we'll do what's called numerically, where we look at, t equals 25, and then maybe t equals 25.0001, and find the average rate of change between those two, and that will be a proxy for the instantaneous rate of change at 25. It's not exactly right, but it's the best we can do in this problem. And the last part of the problem, find an equation for the tangent line. So here in E, you found the slope of the tangent line, and now you're going to go one step further and find the equation for the tangent line. This will require a little bit of work because you have to find a point on the line, but you know that what t will be for this date, and so just put that t into the formula and you'll have your output value. You'll have a point on the line that you're on the tangent line and on the function, and then you have found the slope in here. Use point slope formula and you should be able to do that. The last problem is you've got this picture and they ask you to put in order all of these things. So 0 is given to you. That means that 0, everything that's negative has to come before 0. Everything that's positive on this list has to come after 0. Some of these are negative and some of them are positive. The best bet is probably draw a tangent line at each of these x values and see what you think the slopes of those tangent line, how they would look in numerical order.